Student, welcome to the course of power distribution and utilization. Uh, Today we are going to study about the electric traction system in its types, that is DC electrification system, AC electrification system, and the composite system. So what is electric traction system? It is the system which is used for the electrical power for traction system. Um, it's mean that for railways, trolleys, etc. So we call a system that use electrical power for railways, trolleys, trains, etc. So it is called electrical traction. The track electrification refer to the type of source supply system that is used while powering the electric locomotive system. It can be AC or DC or both in composite. The electrical traction system has many advantages over the non-electric traction system, such as more clean and easily to handle, because here we need no coal and water, easily speed control. We use machines, and it is high efficiency and low maintenance, and running cost is required. So that's why it has more advantages than the non-electric traction system. The three main types of electric traction system are as follows: DC, AC electrification system, and composite system. We will see one by one and how it works and its advantages and disadvantages. So the first one is the DC electrification system. The choice of selecting DC electrification system have many advantages, such as space and weight consideration, rapid acceleration and braking of DC electric motors, less cost compared to AC system, less energy consumption, and so on. That's all its advantages when we using DC system. In this type of system, three-phase power received from the power grid is converted to low voltage and converted into DC by the rectifier and power electronic converters, as we are using AC and producing AC in our grid. So first of all, we need to convert it into low voltage, then into DC. Due to high starting torque and moderate speed control, the DC series motor are extensively used and employed in the DC traction system. They provide high torque and low speed and low torque at high speed. So because of high starting torque and good speed or moderate speed, we use DC series motor in this system. The advantages of DC electrification system, that is in case of heavy trains that require frequent and rapid acceleration, DC traction motor are better choice as compared to AC motor. The next one is that DC train consume less energy compared to AC unit for operating same service condition. The equipment in DC traction system is less costly, lighter, and more efficient than AC traction system. It causes no electrical interference with nearby communication lines, means the DC system has no interference with the communication lines. The disadvantages of DC electrification system is that is expensive substation are required at frequent intervals, because we need conversion from AC to DC and low voltages, the overhead wire or third rail must be relatively large and heavy, and voltage goes on decreasing with increase in length. The second one is AC electrification system. In AC traction system has become more popular nowadays because mostly we generate AC, and it is more often used in most of the traction system due to several advantages: quick availability and generation of the AC that can be easily step up and or step down, easily controlling of AC motor, less number of substation required in the presence of a light overhead line that transfer low current at high voltage, and so on. We generate AC, so when we use AC electrification system for traction purposes, that can be easily step up or step down using transformer and easily controlling AC motor. The substation required is less because in DC we have with the passage of time, with the passage of length, the voltage drop, but here it is not that much common. The supply system of AC electrification includes single phase and three phase or composite system. In AC electrification system, the supply may be single phase, three phase, or we can use both of them as a composite system. The single phase system consists of 11 to 15 kV supply at frequency 16.7 Hz and 25 Hz to facilitate variable speed to AC commutation motor. It uses step-down transformer and frequency converters to convert from the high voltage and fixed industrial frequency. In AC three-phase system, the three-phase induction motor is used to drive the locomotive, and it is rated at 3.3 kV to 16.7 Hz, mean the frequency and the voltage. The high voltage distribution system at 50 Hz supply is converted to this electric motor rating, this one, by transformer and frequency converters. The AC electrification system advantages: fewer substations are required, lighter overhead current supply wire can be used, reduced weight of support structure, and reduced capital cost of electrification. The disadvantages: significant cost of electrification, increased maintenance cost of line, overhead wire further limit clearance in tunnels, and upgrading need additional costs, especially in case of there are bridge and tunnels. So that is the disadvantage of AC electrification system. Now composite system or multi-system, as the name suggests. In this system, trains are used to provide continuous journey along routes that are electrified using more than one system. It may be single phase or three phase, or even sometimes DC. One way to accomplish this by changing locomotive at the switching station. These stations have overhead lines that can be switched from one voltage to another. Another way is to use multi-system locomotive that can operate under several different voltage and current types. In Europe, as an example, it is common to use 4-system locomotive, 1.5 kV DC, 3 kV DC, 15 kilowatt, 16, that is its frequency, and 25 kV, 50 Hz AC. So these are the electrical traction system, different system used, that is AC, DC, and composite. Thank you.